So in this question, we have an equation and we're given some masses for some of the chemicals in the equation. So as you can see, what I've done is put the numbers underneath the chemicals in the equation. And this depends on us remembering the law of conservation of mass, which says the mass of the reactants is equal to the mass of the products. So in that case, all I need to do is 8.00, take away the 6.213, and that's going to give me the mass of carbon dioxide that has been produced during this reaction. So I plug those into my calculator and I get that as an answer. The next one says we've got a second sample of this calcium carbonate. The calcium oxide remained is this value, and then the theoretical yield is this. So calculate percentage yield. So percentage yield as an equation is the actual mass produced divided by the theoretical mass produced, and then we times the whole thing by 100. So this example, they actually had 5.450, and then the theoretical amount is 5.600, and then we multiply the whole thing by 100 in order to work that out. And the answer I'm getting here is 97.3%, rounded up, just to make it easy to express the answer. Okay, part two is the mass of solid left in the crucible is less than the theoretical amount. Reasons why. So remember, it's always going to be less. Experiments never work as they do in theory. So the options here, let's just go through each one of them. I'm going to work my way up. So the decomposition was incomplete. We actually said up above that wasn't the case in the actual question. Some carbon dioxide remain in the crucible. That's not the case because the gas will escape. The solid remained absorbed from the water from the air. Not the case. So the only sensible option here is that some of the solid was lost from the crucible. Right, another experiment we've got going on, and it says the calcium carbonate's been heated. Results are shown. Explain the trend in these results. So different ways of looking at it. You could look at it here at the beginning, and you've got a change in mass there of 0.9 at the very beginning, and then again it's 0.9 in there, I think. And as you come down here, you're only getting a mass change there of 0.1, and that's a mass change of 0.3. So to answer this question, I would, and it's 2-mark answer, I would say that the reaction loses mass as time increases. There is more mass lost at the start of the reaction than is lost at the end. Okay? It's impossible to tell from the data it's incomplete. Why? Well, the reason is because the mass here is continually changing, and therefore we don't know if the reaction's finished. What you would have done is heat it again, and on the 8th minute, if you'd have got the same answer, then you know that the reaction has stopped because the mass is no longer changing, and therefore the reaction is complete. So why is it impossible to tell from this situation is because the mass continues to change you would want the mass to stay, to stay the same to show the reaction is complete. Okay, and then the next little bit, calculate the relative formula mass. So the relative formula mass for CaCO3. So the best way of doing this to check you don't get any mistakes is in this formula is 1 calcium, there is 1 carbon, and there are 3 oxygens. Then put the relative atomic masses in, so that's going to be 1 times 40, which is 40. You've got 1 times 12, which is 12. And then I've got 3 times the mass of oxygen is 16. So that's 6, 12, 18, 48. Add those up. So that's going to be 0. And then you've got 4, 8, 9, 100 is the final answer for that one. Okay, and the final question is work out the atom economy for this reaction. So the first thing to check in here is what is the desired product. So it says calculate the atom economy for the formation of calcium oxide. So I'm trying to get this. And the equation to work out atom economy is it's the mass of the desired product divided by the total mass of all the products. So if in here I'll do the working out up here for us. In here we've got calcium is 40 plus oxygen. That's going to give me a mass of 56. And then here I've got carbon is 12. 2 lots of oxygen is 16 times 2 is 32. And that's going to be then 44. So all I need to do is the mass of desired product, according to that, is 56. All the products is 56 plus 44, and then we times that by 100, and that's going to give me, when you plug it into your calculator, 56%.